the Sequest is competitive. Briefly, the thought process behind why polyphosphates are acceptable even though you've had excursions is it appears that early anyway the dosages were not high enough. It also is went to there's a thesis, really good thesis prepared by I think Virginia Polytechnic, and I know it's good because the professor that managed to taught at CU right after and I know him, he's really good in chemistry. So that's a reliable, even though it's a doctoral thesis and done by somebody who had been on the field, it's very reliable, good thesis. It says there's a problem with polyphosphates. They lose their effectiveness, and this is not black and white, but they lose their effectiveness probably because of stagnation. And they don't mean stagnant water, like you think about it, but they mean water that sits in place in a system, like in a tank or a pipeline, a long time, or a slow-moving water. Polyphosphates lose their effectiveness. Or not lose it, but it's diminished anyway. So, based on this, we kind of went through it, and I believe that the reason for the excursions were that the samples were probably old water. And we did do a kind of analysis to see if the system way out in the south had higher copper than the system inside, and it indicated that, but it wasn't enough data to make it conclusive. But I still think it's a plausible explanation. And
so what you're saying is houses that are sitting and there's no one using the water for extended periods of time.
Yeah, and I'm sure the district staff didn't know that. They probably thought it was okay to sample where you wanted, but because you have seasonal people and people don't use a lot of water, and you have long pipelines, you probably have a relatively old water, particularly in the south system, and you have a really relatively old water when somebody hadn't been there for 3 months in the house. So I believe that is the logical explanation of why you had excursions with the polyphosphates, and that conclusion then said polyphosphates are a reasonable alternative at Vaca Grande. And waters and systems are all different. You have to tailor it. You can't say it worked over here, so it's going to work here. And that's why the state, I'm getting a little ahead of myself here, that's why the state allows you an 18-month study period. You have to do it and verify it in the field. You can't just verify it in the lab that it works. You have to verify it in the field with that system that you're actually putting the water into. The other option is to feed alkalinity, and we have, and state requires, we have to evaluate 3 or 4 optional chemicals to increase the pH, increase the alkalinity of water, so that we get a calcium carbonate equilibrium, so that the water isn't corrosive. And we went through that exercise, and then that's why we took the samples and treated them. We can't treat it down at your plant and then figure out if it works. We did it in a lab scale, treated that water, and came to conclusions. The conclusion from that is, well, there's options. Lime is an ideal chemical to use, but Steve would hate me forever if we put a lime system in because it's a real pain to take care of. It clogs, it's extremely hard work. If we had designed the system initially to accommodate lime, it would be okay, but you can't retrofit with a reasonable amount of money. So we kind of left lime out. Soda ash is caustic is a good chemical too, except that it's dangerous. It's a hazardous chemical, and system this size, if you got any options, you just don't want it to mess with hazardous chemicals. So we kind of did not get prices on that. Sodium carbonate is a good option. That's what generally systems in this area use, and we price sodium carbonate as an alternative, and from the testing results show that 12 milligrams per liter of soda ash will effectively get you a pH high enough in your alkalinity, so your Langmuir index plus indicates non-corrosives. In the actual field, it'll probably be a little higher than that, because we did not have a chlorine correction, and because you may have some demand in the system, I don't know. But it's still relevant, it's good relevant dosage. The other possibility is magnesium hydroxide, and I looked into that because you're feeding magnesium hydroxide at the wastewater plant for alkalinity, and you need that for your wastewater treatment. Has to get nitrification, you have to have alkalinity, so that's the reason to feed it. The problem with magnesium hydroxide is what you use at the plant is not food grade NSF approved. So at this point there is no supplier that produces a food grade liquid magnesium hydroxide. However, we did find one supplier that would furnish food grade solid magnesium hydroxide, which would work as an alternative. I just didn't put that in there because, again, you have that one supplier problem.
Is it a lot more expensive?
Not a lot more, no. Well, the original quote I had, I'm going to diverge a little bit here. The original quote I had was like 3 times as expensive. And I talked to another guy in the same outfit again, and he quoted a price that was competitive. But again, with one supplier, you just, I don't know, if you have another choice, you just don't hang your hat on one supplier. You might use them as an alternate. Anyway, the feed equipment that we propose for this system, you can use either one. It works for either one, so we can change based upon, we don't want to change just for that, because every time you change, you have to go through this testing program again. But we could change. And if they had add with a food grade mag hydroxide liquid, I think you would change if that became available. The comparative costs, with comparing a probable dosage for polyphosphate and a probable cost for adding alkalinity, we had to synthesize, gotta go back just a little bit here, we had to synthesize the system demands, because right now, what we figured out from your numbers, and then I got the HRS report that's not too old, shows we got a lot of leakage. And I'm telling you, the leakage problem would cost you a lot more than the corrosion control problem, if you're correct. But so that's the same thing, but to get an optimum plan, knowing that you need to correct the leakage, and to get an optimum plan that's going to last you for more than a year or two, we kind of said, well, a reasonable number is this, with a reasonable correction of leakage, so this is what we're going to use for cost comparison. Cost comparison shows that, and none of the costs are so high that would say, you would say we can't do that. It's just, they're relatively low in the system costs. The cost says that alkalinity costs more than polyphosphate, and a little bit more. But fortunately, Steve took me down to the sewage plant, and you were using magnesium hydroxide. Of course, I think, you know, if we had it at the water plant, we'd kill 2 birds with 1 stone. We deducted the savings that you would have at the wastewater plant, and that makes the alkalinity less costly than the polyphosphate. But that's only true, that's all relevant again. If I waste half of the water out in the ground, then that alkalinity doesn't get to the sewage plant. So that's only true providing that you correct your leakage problems. But I think it's a valid comparison to get what we really have to look for, which is called the optimum control plan. And you don't want to do this, you don't want to change every few years. So this is, I think what we have is an optimum plan that over the long range, but to measure with that, you have to correct your leakage problems. So I think that covers the highlights pretty much. The estimated capital cost of converting is not high. You can have a high-tech feeder, a dry feeder, but we just got to simplify it because it's not such a big system. But with that, the capital cost is about $15,000 to convert. Of course, if you save the polyphosphate, your capital cost is 0 because you already got it. So there are more subjective comparisons in the report. The subjective comparisons, one is that although you're not required to now by the Department of Health, there are plants, wastewater treatment plants that are required to remove phosphorus. Phosphorus is considered a contaminant in wastewater. So, particularly like at Silver Car, we got a 4 million gallon a day plant there. We want the participants not to use polyphosphates because we have to take the phosphorus out at the other end. That's not a problem here now, but environmentally it's preferable if we don't discharge more phosphorus into this aquifer than we do. Although here it's not a big deal because we're not talking about a lot. There is a reported, and I'm not sure it's true, there's a phosphorus shortage looking at the United States. Phosphorus is becoming a critical element. And if everything was even, I would not use phosphorus just because I don't want to use phosphorus. Because it's got other uses that we need. It's a limited element.
Resource.
Yeah.
Mm-hmm.
Those are the other thing is I believe that because you have this, these are relatively not major reasons or minor reasons, but a little bit better. Because you have this fairly high intermittent users here with that you don't have. There are houses here that don't get used every day. Mm-hmm. And there's it's a very low density system in our vernacular. It says that because it's a long way from here to here, you don't have very customers, it takes a long time for water to get the plant down to the south end. Mm-hmm. So you do have this stagnant water problem, and I believe that that says that the alkalinity is going to be a little better because it's more stable. It stabilizes the water, and once you get any demand taken care of, it will probably last longer than the polyphosphate.
Okay. So let's talk a little bit about the process. So, you're recommending soda ash, right? I mean, that's the common term for the chemical, right? Okay. And if we were to, move in that direction, and of course the board has to make a decision, if the district decided to move in that direction, what's the next step in the process? Do we have to work with the health department to do that?
Yeah, I think you'll see in Sharon's letter that I believe you may remember this better than I do, but I think it's by March 15th or sometime in March this year, we have to have the first report, which is basically this report. It's a preliminary. If they approve this report and they agree that their OCCT is consistent with what we recommend, then your next step is to, if you decide to implement it, is basically do a little plan and spec, send it to the health department and get the plan and specs approved. And